Alright guys, welcome to the review video for chapter 11 on circles. I'm just going to go ahead and begin working it. You may watch this forward to the problems that you need, or you may watch the entire video, it's up to you. Okay. The very first part up here is vocabulary. I'm not really going to go over that. I think you can handle that on your own, so I'm just going to go straight to the problems. So we'll start at number 5. Okay. When I look at problem number 5, the first thing that I need to ask myself, x is what? I'm giving you x's here, so, and I'm also giving you a clue that in degrees, so I'm looking for an angle. This angle is located on the outside, so I'm going to go ahead and highlight the angle. So this is the angle that I have. Okay. Now, why do I do that? Because now I can see the intercepted arcs. I see that this is intercepted from here to here, and I can also see that this is intercepted from here to here. Alright. Now, if you remember the formula for an outside angle, it's outside angle. Matter of fact, I don't have space to write it down, so let me grab the formula chart. Give me just a second. Okay, I'm back. Sorry, I just don't have enough space to write it down, but here it is. It says the outside angle is equal to the big arc minus the small arc divided by 2. So I'm going to use that to help me out. I'll put to the side. Now, that means I'm going to need this purple area minus this red area divided by 2. Okay. Now, 138 was given that was my central angle. You remember that central angles and its arc are 138, which means that this is also 138. Because this thing is forming an entire circle, in order for me to find out this purple area right here, I'm going to take 138 and subtract it from 360. So 360 minus 138 gives me 222. So that means that the big arc is 222 degrees. Now I have everything I need. It says big arc, so 222 minus the small arc divided by 2 will give you your outside arc. Outside angle, pardon me. Your outside angle. Okay. So I'm going to go ahead and go into my calculator and just plug this in. So alpha y equals enter to get a fraction. 222 minus 138 divided by 2. I hit enter and I get 42. That means that your outside angle is 42 degrees. Alright, fantastic. Let's move on. Number 6. Alright, the first thing that I notice here is that I'm not dealing with angles. So if I'm looking at this formula chart, I'm not looking, this won't help me, this won't help me, neither would that or that. We have not even talked about this one or that one. The top part is not going to help me, you haven't seen it, so maybe one of this, but let's see what I have. I have a tangent line, okay, and I have a right triangle and a radius. Okay, that's nothing that we have here, but last class we learned that when you have a tangent and a radius, they are perpendicular. Now how is that going to help you? Well, as you can see now, you have a right triangle. For a right triangle, we have to use Pythagorean theorem. Okay, Pythagorean theorem says that it is a squared plus b squared equals c squared. So I'm going to call this a, I'm going to call this b, and c has to be the hypotenuse. Okay, so a squared, so in this case it's going to be x squared plus b squared, which is 24 squared. It's going to be equal to the hypotenuse. Okay, well, we don't have the hypotenuse. However, we have the distance that from here to here is 18.0. So I'm going to have to get a little creative. I know that the distance from here to here is the radius, because the distance from the center to anywhere on the circle, outside of on the circle, I'm sorry, is the radius. Well, wasn't my radius x, so I'm going to call this x as well. Now, from here to here is x, and from here to here is 18. So altogether, to find out what it is, I would have to add them. So it will be 18 plus x. That's your hypotenuse, but you have to square it because we're using Pythagorean theorem. Okay? Now, from here is just, let's see how good your algebra skills are. X squared is not going to simplify, we're going to leave it as x squared. Plus, well, 24 squared, if you go into your calculator, it's going to be 576. Now from here you got to remember that 18 plus x is the same thing as saying 18 plus x times 18 plus x. Okay? Alright, we're going to continue to work on this. So x squared plus 576 is not going to simplify. Now remember, when you have a problem like this, you have to distribute. You got to do 18 times 18. So 18 times 18 is 324. And then you do 18 times x, so that's 18x. X times 18, that's another 18x. And then x times x gives you x squared. Alright, notice I'm writing really small. I apologize, I'm just running out of space. Okay? Alright, from here I'm just gonna combine like terms and start solving from here. Okay? So let me draw a dotted line there so you don't get confused. So x squared plus 576. Okay, I have the x squared, so I'm gonna leave it alone. 18x plus 18x, that's going to give me 36x, so plus 36x. And then I have that 324 plus 324. Alright, I've combined everything that I can. Now I just have to solve for x. So I'm going to subtract x squared from both sides. And they're going to cancel out, so that's fantastic. So that leaves me with 576 equals 36x plus 324. We're going to subtract this from both sides. So that leaves you with 36x equals, well, 6, that's 2, that's 5, 252. Lastly, you would divide by 36. So it would give you 252 divided by 36 is 7. So x is 7. X is 7. Alright, that was a little tough problem, but let's keep going. Alright. Number 7 is actually a relatively simple problem. The first thing I notice is that I'm dealing with chords and that they're equidistant from the center. And two chords that are equidistant from the center means that they are congruent. So that means that chord BA is congruent to chord CD. Now, more importantly, when chords are congruent, then you know that their arcs are also congruent. Okay? Now, because it's asking me for arc BC, that means I'm looking for this part right here. Let me use a different color. From here to here. Okay? Now, well, how is that going to help me? How am I going to figure that out? Well, I know this is 100 and I know this is 135. You know, however, that this arc right here, hold on, let me use a different color. This arc right here, you should know what that measures. It's 100 degrees because these two chords are congruent. Okay, so now that you know that this is 100, that's 100, and that's 135, you should have no problems finding out what BC is. So what I'm going to do is I'm going to add them all up. So 100 plus 100 plus 135 minus 335. That means that arc BC is 25 degrees. Okay? Very good. Alright, let's continue on working on this review. Alright, number 8. We're looking for the perimeter. So the perimeter is going to be all of this. Okay? It says quadrilateral JSEH is circumscribed about a circle. So we got a circle. JS, so from J all the way to S is 16. PE, from P to E is 5. HJ, the entire thing here is 18. HX is 9. Okay, alright. Let's see. So how are we going to solve this problem? Well, let's figure this out. Okay. The first thing that I notice here is that I have tangent lines. Okay, tangent lines, remember, are lines that touch the circle at one point. For example, JS, line JS is tangent, line SE is tangent, HE is tangent, and JH is tangent, because they're only touching the circle at one point. Now, we learned last class that when you have two tangent lines originating from the same point, so for example, look at this point H. Do you see how you have tangent lines going from here going on to that direction? Okay. If you remember, when you have that happening, that means that the distance from that point to the point of tangency are going to be congruent. So from here to here is 9. That means that from here to here is also going to be 9. Okay. Now, remember how they gave you this 18 from J to H, and then but they told you that from x to h was 9. Well, that should be enough information for you to figure out that this is also 9, because 18 minus 9 is 9. Alright, well, how is that going to help you? Well, we have the same situation. We have two tangents, so JS and JH, coming from point J. If from J to is 9, from J to A will have to be 9. Okay? And now we can use the 16 that they gave us. Well, the entire thing is 16, but from here to here is 9. 16 minus 9 is 7, so that's 7. And as you can see, I hope you're recognizing the pattern. This would have to be 7, because they're both originating from point S. Since this is 5, from P to E, that means from E to R is 5. So I think we have all the numbers that we need. Okay, so let's add them up together and see what we got. Be careful not to get confused. We no longer need these numbers right here, the 18 or the 6. We only need the ones I'm going to highlight. Okay, so let's add them up together. So we have 9 plus 7 plus 7 plus 5 plus 5 plus 9 plus 9 plus 9. Okay, hit enter and I get 60 units. So since it's perimeter and I didn't give you any units, you actually do have to write the word units. Okay, 60 units is your perimeter. Fantastic, we're coming along very well. Okay, number 9. It's asking us for AB. Well, what is AB? In this case, AB is from here to here, so it happens to be a chord. So I have to try to remember what I know about chords. Okay. Well, all I'm given is that I have a distance from here, from the center to this point is 13, and from here to here is 9. But this is interesting. They are telling me that this line right here and this line are perpendicular. And if you recall your rules of chords, when you have a radius, which by the way, your radius would be located from here to here, perpendicular to your chord, which in this case is from here to here, then you know that the chord gets bisected. So what that means is that from A to this point is congruent to from this point to B. Okay? Well, how is that going to help you? Alright, well, let's talk about this. We know that this is 13. We know that this is 9. So we don't know this and we need to figure this out. Because I have a right angle, maybe I'm thinking, how can I solve this? What if I, for example, draw this right here? Now I have a right triangle, and I know how to deal with right triangles. I can use Pythagorean theorem. However, to use Pythagorean theorem, I need more than one number. I only know this is 13. This is what I'm looking for, so I need to know what this is. Is there enough information for me to figure that out? Well, in reality, there is. And all you have to do is ask yourself, well, from O to A, that's a radius. Do you agree? Because you're coming from the center and you're going to the out to the edge of the circle. Now, is there any other place where you see a radius? Well, you do have another one. It's from O to C. From O to C, it's a radius as well. Well, how is that going to help you? Well, you know that from here to here is 13, and from here to here is 9. So how much is the total radius? Well, 13 plus 9 will give you 22. It means that your radius is 22, which means that AO is 22. Alright, so now you know this is 22, you know that's 13, and this is what's missing, so I'm going to call it X. We have a right triangle. I'm going to redraw it, where the hypotenuse is 22, one of the legs is 13, and this is X. I'm going to use Pythagorean theorem. So it's X squared plus 13 squared equals 22 squared. Okay? X squared plus 13 squared is 169. And 22 squared is going to be 484. Alright, I'm going to subtract 169 from both sides. X squared equals 484 minus 169. Let's see what that gives me. 315. Alright, so now I'm going to find out what X is by taking the square root of both sides. So the square root of 315 is approximately, when I try it on my calculator, 17.5. Okay, so am I done with the problem? No. because what I know is that 1775 is from here to here. And that's not what it was asking me. It was asking me for A to B, so the entire thing. But remember how I labeled this at the beginning, how this is congruent to that? Well, if this is 17.75 and this is 17.75, well, 17.75 plus 17.75 equals to 35.5. And that would be our answer. Okay. Pause the video as much as you need it while you're working this, and then just hit play when you're ready to go. So I'm going to go ahead and move on. Number 10. Alright, number 10, we have a similar situation just like number 9. We have this being parallel, not parallel, perpendicular, my mistake. You have a chord, you have the diameter. If you keep going, doesn't that make the same rule that we did where you have a radius and a chord being this part right here is congruent to this part right here? Alright, so we'll keep that in mind. Maybe we'll need that. But I think I'm going to try the same thing we did on the previous problem. I see a right angle. I'm going to see if I can make a right triangle. Now, I have drawn a radius. What's the measure of my radius? Well, I am told that from here to here is 32, and isn't that my diameter? Well, isn't a radius half of the diameter? So if I take 32 and divide it by 2, 32 divided by 2 is 16. And now we have the same problem that we had previously, which is a Pythagorean theorem problem. So I'm going to say this is x squared plus 7 squared equals to 16 squared. X squared plus 49 equals 16 squared is 256. I'm going to subtract 49, from both sides. So that gives me x squared equals 256 minus 49 should be 207. So I'm going to take the square root of both sides. That means that x equals, let's find out, square root of 207. When I plug that in my calculator, I got about 14.39. So let me make sure I answer the question. What was this asking us for? Was it asking us for the entire chord? No, this one just asking us for here to here, so that means that I am done. 14.39. Fantastic. Alright. Next question. 11. Interesting. I see that I have secants. I have a secant, and why is secant? Because it's intersecting at 2 points, but it's going outside the circle, and so is here. So secants. What do I know about secants? Hey, there was those formulas. Let me bring them back. Maybe they'll help me. Okay. That was the ones that we learned last time, so it was one of these three. Okay. Now, when I look at these formulas, this one says part. Maybe that one, because I see like this is one part, that's another part, that's a part, that's a part. But let me look at the other ones, and maybe you'll bring back your memory. Well, this one's more specific. It says outside part, and there is an outside part, so maybe it's that one, but maybe it's that one. But this one says the difference between both of them is that this one has outside part only, as opposed to this one has outside part times the whole. So my intuition tells me that we have to use this one, but if you do actually remember, then you will recognize that you have to use this one, where it's the outside part times the whole thing equals to the outside part of the other secant times the other entire secant. So what that means is, on the secant that I'm going to highlight here, in the outside part of it measures 12. So according to the formula, I have to take the outside part, so I'm going to say 12. And then I multiply by the whole secant. So the whole secant is 12 and 4, that's 16. It says that's equal to the other one, which is this one right here. Well, the outside part of it is x, but the entire thing is x plus 16. Okay? So now we just have to solve here. So on the left hand side, 12 times 16 is 192. And here you have to distribute, remember. So x times x is x squared. And then x times 16 is 16x. Alright. From here, okay, it all depends on your algebra skills. You have a quadratic, which means that you have to the power of 2. If you recall back in solve a quadratic is by bringing everything to one side and making it equal to 0. So what I'm going to do is I'm going to subtract 192 from both sides. What's that going to cause is that's going to cancel out. So in reality I have 0 on this side, and it's going to be on the other side I have x squared plus 16x minus 192. Okay. From here, now your quadratic equals to 0. Now you have to kind of go back to Algebra 1 and try to see if you remember how to factor. Okay, how to factor this quadratic so that we can solve. I believe the method that most of you guys have been introduced to is to use the box method. Okay, which is when you draw a box, a 2 by 2 box, where you put the x squared term here, you put your constant here at the bottom, and in here you gotta find two numbers that multiply to 192 but add up to be 16. Okay, now the only way you're gonna get two numbers to multiply to be a negative, one of them has to be a positive and one has to be a negative. Okay, so we're going to keep that in mind. So what I like to do is I like to use a calculator to find out what numbers give you 192, multiply to be 192, but add up to be 160. So the way I do that is I use my calculator and I go into y equals, because I'm going to use a table to help me out. So what I'm going to do is I'm going to take the 192 and divide it by x. Well, how is that going to help you? Well, if you go to the table, let me change something in my calculator real quick. If you go to the table, sorry, go back again. Here you are. If you go to the table, then you can see all the factors. For example, 1 times 192 gives you 192, but that's not going to help us because that doesn't add up to be 16. 2 and 96, too big. 3 and 96, that's too large. 4 and 48, that's too large. 6 and 32, we're still way up there. Let's keep going and see if we find something. Well, 8 and 24. Hold on, that kind of seems interesting. Well, 8 and 24, if we need a positive 16, then that means that I'm going to make 24 positive, but we need a negative number, so I'm going to make that a negative. Okay, 24 minus 8 is 16, so that's kind of what I'm looking for. So in other words, you can rewrite this as x squared plus 24x minus 8x minus 192. This and that is exactly the same, because if you combine 24x and negative 8x, you get the 16. Well, how is that going to help you? Well, now, because you broke that up, you can use those numbers to fill in your box. So that's going to be 24x, and I'm going to put the negative 8x there. It doesn't matter where you put it. You could have put the negative 8x here or the 24x there. Okay. Well, now, how is that going to help you? Well, let's go back to Algebra 1 and see if you remember how this works. You got to look at this first row here and ask yourself, is there anything in common between this one and this one? And there is. I see an x in common, so I'm going to factor out an x. Alright. Now, this second box, I'm going to look, is there anything in common between 24 and 192? Okay, well, most of you guys don't know this on top of your head, so first let's check. Maybe 24 in common. So I'm going to use my calculator. Is 192 divisible by 24? And it is. So that means that I can factor out a 24. Alright, so we're making some progress. Now, when you're looking at the box, first you can do the horizontals. Now we're going to do, so you're going to encounter here that vertically they have in common an x. And on this one, well, they both have a negative, so I'm going to pull out a negative. And I'm sorry, I've kind of bunched up the work there. Now, 192 and 8. Does 8 go into 192? Well, let's figure it out. 192 divided by 8. And look at that. It does. So I'm going to factor out an 8. Now, how can you check that you've done this correctly? Well, you can check the following way. X times x, x squared. Fantastic. X times negative 8, negative 8x. Great. 24 times x, 24x. Awesome. 24 times negative 8 is negative 192. So you factor this correctly. So I'm going to kind of go in this direction because I ran out of room. So just follow my work. I'm going to take this statement and this statement right here, and I'm going to rewrite it, but now using factors. So what I know is that x squared plus 16x minus 92 is the same thing as saying x minus 8 times x plus 24. And note that that was equal to 0, so I'm going to set it equal to 0. Now, why did I factor that out? Because if you remember from Algebra 1, now you can take each one of your factors and set it equal to 0. So for example, this is one of the factors, so I'm going to say x minus 8, set it equal to 0. And this is the other factor, x plus 24 equals to 0. And solve for x. So from here, if I add 8, that means that x equals 8. Okay? And here, if I subtract 24, that means that x equals to negative 24. Now, you have two responses, but it's not possible to have two responses for the problem that we have. You have to logically think. We're talking about a distance here. Can a distance be negative? No. The negative is direction, and as far as this class goes, you still don't really haven't been taught what that negative does in direction. That's going to be more on physics and pre-cal, or in the future if you decide to take those classes. So for the moment, the only thing that makes sense right now is to have a positive number. So the only answer that's positive in our case is 8. So x would have to be 8. That one was a challenging problem. Very good algebra review. Okay. Alright, let's move on. 12. Alright, I have two chords. And last time we studied chords, and I remember there was a formula. And now that I kind of went through 11, I know right away that I have to use this formula right here. Okay. Now it's part equals part. If you don't remember, well, here is your entire chord, but here's one part of it, and here's the other part of it. So that means part times part, so that's 5 times x, that's 5x, equals the other one, which is parts, so that's 12, times the other part, which is this part right there, so 12 times 3. Okay, so 5x, there's nothing I can do, but 12 times 3, well, 3 times 2 is 6, that's 36. Cool? I'm going to divide by 5, x equals, if I go into my calculator, 36 divided by 5, it's 7.2, but I don't really like decimals, so I'm going to leave it as a fraction. So I'm going to hit math, enter to get the simplified version of it, and it doesn't get any simpler than that, so it's 36 over 5. Alright, let's keep going. 13, word problem. Let's see what we got. Paula drew a circle P, so here's circle P. She constructed a radius, PW, perpendicular to a chord, okay, AB. Okay, so I'm going to throw this in there. This is perpendicular. Based on this information, which of the following is true? Alright, let's see what's it. PX, so PX is congruent to XW. What we do know, let's go ahead, we already know without even looking at this information. When you have a radius that is perpendicular to a chord, we know that this is congruent to that. So let's look up for the option that says AX is congruent to XB. AX is congruent to XB, and that's all we know. The other options are not possible. Okay? Alright, let's keep on moving. 14. You have JK and JM are tangents. Okay, that's important. They're tangents to the circle. Find X. Alright. They're both originating from this point, and they're tangent to circle L. So if you recall, when you have two tangents originating from the same point, they are congruent to each other. So in this case, that means that this is equal to that. So 3x squared plus 5x minus 10 equals to 3x squared plus 2x plus 44. Alright, so I'm just going to solve here. I'm going to subtract 3x squared from both sides. That cancels out, leaving you with 5x minus 10 equals to 2x plus 44. Alright, I'm going to subtract 2x from both sides. That gives you 3x minus 10 equals 44. Almost there. Plus 10, and I kind of ran out of space, so I'm going to go right here. So, that's a horrible error. So negative 10 plus 10 goes away, so leaves you with 3x, and 44 plus 10 gives you 54. I'm going to divide by 3. That cancels out, so x equals, well, 5 divided by 3 is 1, and you have 2 left, 2 and 4, that's 24 divided by 3, that should be 8. Okay? And you can do it on the calculator if you want to try it. 54 divided by 3 is 18. So x is 18. Let's make sure that's what they were asking us for, and that's all they were asking us for. The answer will be 18. Alright, just keep on moving. Just a friendly reminder, pause the video as you need it. Okay, I'm just going to keep working, so if you need to pause the video, go ahead and do so. Alright, 15. GPS satellites orbit around 1,100 miles above Earth. The mean radius of the Earth is about 3959 miles. Because GPS signals cannot travel through Earth, a satellite can transmit signals only as far as point A and C from point B, as shown. Find BA to the nearest tenth of a mile. Alright, interesting. Here's what we know. We are looking for BA. So I'm going to highlight what BA is. Okay. Here's the only thing that we know. We know that from here to here is 1,100, and we know that from here to here is 3,959 miles. How can we figure this out? Well, if you recall, the center of the Earth is here, and when you have tangent lines, so if this was to continue going on that direction, the tangent line and the radius, if I draw my own radius, they make a perpendicular or a 90-degree angle. Well, how is that going to help us? Well, we're looking for this, so I'm going to call it x. We know that the distance from here to here is 11,000, and we know that the radius of the Earth is about that much. Well, didn't I just draw a radius here? So doesn't that mean that this is also 3,959? Do you see how I have a right angle? Okay, this one's going to be a little tougher to solve. Remember, I'm going to use Pythagorean theorem. So a squared plus b squared equals c squared. So I'm going to use this one right here. So x squared plus b squared. Ooh, that's going to be a huge number. 3,959 squared equals to the hypotenuse. Well, how much is the hypotenuse? The hypotenuse is this entire thing. So let's go ahead and add those up. So 11,000 plus 3,959. 14,959. 9,059. And that number square, this is going to be a huge number. And it makes sense that it is, because we're talking about, imagine how far this satellite has to be from Earth, from the center of the Earth. Okay? Alright, so the x squared is going to stay alone. Now, 3959 squared, so 3959 squared equals to that entire number there, so plus 15,673,681 equals, I don't even want to know what that is, but let's look at it. 14,959 squared. Let's see, 22, 37, 71, 681, 223 million. Okay. Alright, so we're dealing with some huge numbers, so you gotta be very careful when you're typing this out. Okay. Alright, I want to solve for x. So I need this huge number to go away, so I'm going to say minus 1573. So that's going to leave you with x squared equals, and we're going to need our calculator on this one. Let's go back to it. So it's this entire number right here minus 15,673,681, and it leaves me with 208,098,000. Okay. Last thing is that we need to take the square root of it. So x equals, so I'm going to say second square root of, and if you do second, show you second and the minus sign, notice how in the blue it says answer. It takes your previous answer and inputs it for you. So instead of typing all that number, you could just do that and then hit enter. And that's our answer. Let's see, 14,425.6. Let's go make sure we answer this correctly. It says find BA to the nearest tenth of a mile, so I only need one decimal spot, so that means that your answer is 14,425.6 miles. That's a huge distance, but we want our satellites to be reliable, right? Anyways, pause the video if you need it, and if not, then I will continue working on this review. Alright, we're almost there. We got 5 more problems. Okay? 16. It says find the values of A and B. Okay, so we have a diameter and we have a chord and they're perpendicular. When that is true, that means that this is congruent to that. Now based on that, I should be able to find out what A is, because that means that 4A plus 1 equals to A plus 8. So I'm going to subtract A. That leaves me with 3A to 8. I'm going to subtract 1, so that leaves me with 3A equals to 7. Divide by 3. A equals to 7/3. That's, you can try to plug that in your calculator, but that's not going to reduce. So I'm going to leave it as 7/3 because 7 is a prime number and there's nothing in common between 7 and 3. Okay, other than 1. Alright, for B. Now, let's think about this. Because this is the diameter cuts the circle in half. Okay? Now, let me highlight that. So that means that this entire arc from here to here is 180, and this one's 180. Together makes 360. The moment that I drew this chord here, and the fact that it's perpendicular, it's going to tell you that this arc right here and this arc right here are going to be congruent to each other. And this one is going to be congruent to that one. So because they are congruent, I'm going to say 2b plus 9 equals to 5b minus 6. Subtract 2b from both sides. 9 equals 3b minus 6. I'm going to add 6. 15 equals to 3b. Divide by 3. B is 15 divided by 3 is 5. So your answer should be 5. 17. You have a diameter of 30 centimeters. So if your diameter is 30 centimeters, that means that your radius is 15. So if you notice, you have a radius right here. So I'm going to call that 15 centimeters. The measure of AB, the entire thing, A to B is 24. What is ED? Interesting. Alright, so AB is 24, so that's from here all the way to there, that's 24. But if you remember, when it's perpendicular, that means that it gets cut in half. This is congruent to that, so this is 12 and that's 12. What else do I know? It's asking us for ED. Well, ED is from here to here. However, I want you to notice here, because this is going to get a little messy. From C to D, that's a radius as well. So that's also 15. Now, if I can figure out how much it is from here to here, then I can subtract it of 15 to obtain that. Now, how am I going to do that? Well, I have a right triangle here. I'm going to call this x. So I'm going to say x squared plus 12 squared equals to 15 squared. X squared plus, well, 12 squared is 144. And 15 squared is going to be 225, I believe. Yep, 225. Subtract 144 from both sides. X squared equals, so 225 minus 144 is 81. So take the square root of both sides, so x equals to 9. So now we know that this is 9. However, that's not what it was asking us for. It's asking us for E to D. Well, remember how I said that this is a radius and the diameter was 30? Well, the radius would then be 15. If from here to here is 9, from here 15 minus 9 is 6. Moving on. Okay, we have two tangents. I mean, not tangents, my apologies. We have two chords. You have chord, this one right here. And we have another chord right here. So my formula chart, we did this previously. It's going to be this one right here. Part times part equals part times part. Okay, well, let's start with what we know. We're going to take this one in red. So if the first part is 4, part 5. Now, the other one, this part is x, but wait a second, how much is this part? Well, we know that the entire thing is 12, and we know that this is x. Well, let me use the red one as an example. This one, you know that this is 4 and then this is 5, so the entire thing is 9. So if I knew that this was 4 and I knew the entire thing was 9, so 9 minus 4 gives you 5. So we're going to kind of use the same process. If this is x but the entire thing is 12 and I'm trying to figure that out, then I'm going to take 12 and subtract x to figure out what that is. Okay? Now that I have my equation, we're good to go. 5 times 4 is 20. We're going to distribute. X times 12 is 12x. X times x is, well, you have the negative, so it makes a negative x squared. Uh-oh. We have another one of those quadratics, so let's see if we can solve this out. Typically, you want to have this as positive, so what I'm going to do is I'm going to add the x squared, and I'm going to subtract the 12x from both sides. So plus x squared minus 12x. So when I add it here, it's going to be x squared minus 12x plus 20 equals to 0. Okay? Uh-oh. I think I'm going to have to use that box method again. Alright, so we're going to go ahead and set up my box over here. Top corner, x squared. Bottom corner, I'm going to put the 20. I need to find out two numbers that multiply to be 20 but add up to be negative 12. Well, let's talk about this. We can create this one on our own since the number is not too bad. 1 and 20. Yeah, that's not going to get us 12. Okay. 2 and 10. Interesting. 2 and 12, that gets us 12. So let's kind of think about that for a second. I need it to multiply to be positive 20, but they need to add up to be negative. If these are both positive, 10 times 2, it is 20, but they add up to be positive 12. What if we make both of them negatives? Negative times a negative gives you a positive, and negative 2 minus plus a negative 10 gives you negative 12. Oh, that's going to be it. So x squared minus 2x minus 10x plus 20 equal to 0. These two things, I repeat, are the same. I just rewrote it. So now we know that in here I need a negative 2x, and in here I need a negative 10x. Again, the order does not matter. You could have put the negative 10x here and the negative 2x there. Alright, so we're going to do the same process. In this 2, we can factor out an x. In this 2, you should be able to factor out a 2. Alright, here you have an x in common, and here they have a 10 in common. Okay, now we need to figure out our signs, and the way we're going to do this is by checking our work. Well, x times x gives you x squared, so those two are positive. X times 10 gives you positive 10x, so I need it to be negative, so I am going to make this negative. X times negative 10, good. 2 times x does not give you negative 2x, so I'm going to avoid putting a negative with the variable, so I'm going to put it here. Now, to make sure we actually put our negatives in the right position, this needs to work. Negative 2 times negative 10, positive 20, so it does. So now, what does that mean? I'm going to go here now. That means that this entire statement has now become x minus 10 times x minus 2 equals to 0. I'm going to take each one of those and set it equal to 0, so x minus 10 equals 0 and x minus 2 equals 0. So that means x equals 10 and x equals 2. Okay, so they're both positive. Are they both right? Well, let's think about it. Okay, if we plug it in here, we're going to test our answers. We're going to do, we know that this is 10, so we're going to call this 10. So if the entire thing is 12, and that's 10, then that would have to be 10, right? 5 times 4 is 20. 10 times 2 is 20. So that means that that number does work, so I'm going to say that x is 10. And now if I plug in 2, so if I were to put 2 in there, then that would be 10, and wouldn't it be the same situation? Okay, so it could be 10 or 2. Alright, 19. We're going to find x, and I think we're running into the same type of problem where it's going to be part times part equals part times part. So let's make sure we're using the correct parts for each one though. Here's this chord. So it says, I'm going to take part, so 4 times the other part, which is 2x minus 1, I'm going to set it equal to the other one, which is, in this case, part of it is x minus 2, and the other part is x plus 7. Alright, 4 times 2 is 8x, 4 times negative 1 is negative 4. X times x is x squared, plus 7x, minus 2x, minus 14. 8x minus 4 equals x squared. Well, 7x minus 2x, that's 5x minus 14. Alright. Unfortunately for you, like we're going to run into another quadratic, guys. There's no way I can cancel that x squared out, so I'm going to have to bring everything to the other side. So minus 8x and the plus 4. Minus 8x and the plus 4. That's going to cancel out. That's going to cancel out. That way I have 0. So x squared. 5x minus 8x is going to give you negative 3x. And negative 14 plus 4 is going to give you negative 10. Alright, so we need to find two numbers that multiply to be 10 that add up to be a negative 3. Okay, so let me create my box. I'm going to go up here for a second since I'm running out of space. In here, I need the x squared, and in here I need a negative 10. Okay, the only two numbers that I can think of that can give you 10 and would combine to be a negative 3 would be 5 and 2. Okay, so let's talk about this. So 5 and 2. If I need to be negative, I'm going to say negative 5 plus 2x. Okay, minus 10, because negative 5 plus 2x, that gives you the 3x. Okay, now I'm going to put the negative 5x here. I'm going to put the 2x here. Let's try this out. They have an x in common. These two have a negative 5 in common. This have an x in common. This have a 2 in common. X times x, x squared. X times 2, 2x. Negative 5 times x, negative 5x. Negative 5 times 2, negative 10. Good. So that means we have x plus 2 times x minus 5 equals 0. X plus 2 equals 0. X minus 5 equals 0. If I subtract, then I get x equals negative 2. And if I add, then I get x equals 5. Okay. Now let's check and make sure that our numbers make sense. Okay. If I put in negative 2 there, negative 2 and negative 2, that gives you negative 4. If I put a negative 2 in there, negative 2 plus 7, that gives us 5. If I put negative 2 in there, that's negative 2 times 2 is negative 4, that's negative 5. So let's see. Negative 5 times 4, so negative 2. Now let's see what happens when we put in 5. I'm going to use a different color, so I'm going to use 5. 5 times 2 is 10, minus 1 is 9, so I'm going to say 9. 5 minus 2 is 3, so this one right here is 3. 5 plus 7 is going to be 12. Interesting. Well, 9 times 4, let's check it out. Well, actually, you should know that, but 9 times 4 is 36, correct? And 3 times 12 is also 36. So, our answer is also 5. Okay? Last one, number 20. You've made it this far. Okay? You have two secants. So that kind of reminds me that when you have two secants, you have to use outside part times the whole thing equals outside part times the whole thing. The outside part of that secant is 6. And the entire thing is 6 plus the inside x plus 3 equals the other secant, which in this case is outside part is x, and the entire thing is x plus 4x. Alright, let's try this out. In the inside, you should be able to combine. So this is 6. 6 plus 3 is 9, so 9 plus x. On this side, I'm going to go ahead and distribute. X times x is x squared. And then x times 4x gives you plus 4x squared. Alright, on this side, I have 6 times 9, which is going to be 54. 6 times x is 6x equals to x squared. I'm going to go ahead and combine that, since you know that 4x and 1x are going to combine. Sorry, I needed to get my white out. If you have x squared and you have 4x squared, that means that you have 5x squared. Okay, well, how is that going to help you? Well, I need to get everything to one side, so I'm going to subtract 6x. So this gives me 54 equals 5x squared minus 6x. I'm going to bring over the 54. So that's 0 equals to 5x squared minus 6x minus 54. Oh boy. This is going to be a tough problem to solve by hand. So I'm going to show you a trick on the calculator. Okay? And let's see how hopefully you can kind of remember this from algebra. Okay? I'm going to put this into y equals. So I'm going to go to y equals. Okay? And I'm going to type it in as it is, 5x squared minus 6x minus 54. And I'm going to hit graph. Okay. When I graph it, let me you're probably going to get this window right here. Okay. If I'm looking when it's equal to 0, that means that I'm looking for this spot right here and this spot right here. Sorry. Now, the way you can find out what those numbers are in the calculator, you can either try go to the table and find out when it's 0, but that could take forever because look, you would just have to guess and check. And for this problem, you won't even find it. So the way to do that is if you hit second trace, you're looking for a 0, which is option 2. In your calculator, if you use your arrows, your left and right arrows, you're going to get this little blinking cursor. You're just going to follow the instructions. Notice how that blinking cursor is right here. There's a 0. So at this current moment, I'm to the right. So I'm going to use the left arrow until it's passed. So I'm going to hit enter. Then it says go to the right of it. I'm going to hit the right arrow a few times until I passed it. Enter. Then I hit enter. That's one of your answers. So one of my answer is 3.94. To find the other one, I'm going to do the same process. But now I got to go to the other side. Keep going, keep going, keep going, keep going until you see it. Oh, there it is. Okay. So it looks like it's somewhere around there. But now follow the instructions. It says go to the left, so I'm going to hit the left. Enter. It says go to the right, so I'm going to go one more time because I'm not past it yet. There you go. Enter, enter. So x equals negative 2.74. Alright. I'm going to be honest with you guys. This review was taken from pre-AP. So a lot of these problems were a lot more difficult than what you're going to encounter, but the processes are the same. Okay, don't stress too much about this whole quadratic stuff. It is something that you should know from Algebra 1. However, I will not have problems that require you to know a lot about quadratics. Quadratics will show up on the test, but not as intense as it did on the review. Okay. Hope you enjoy watching the video, study for the test, and good luck.